So now we are going to get into the first exercise 7.1 in your NCERT. This is the first exercise of your integrals. So let us go one by one. The first question is integral sine 2x. So we know the formula for sine x is equal to minus cos x. So integral sine 2x is going to be minus cos 2x. As I already said, if we have any coefficient for x, that coefficient should be written in the bottom as a denominator. So answer is minus cos 2x by 2 plus c. So this is your first question. We'll go with the second question. Integral cos 3x. Cos 3x has a formula as sin x plus c. So then the answer will be sin 3x. As x has a coefficient of 3, it has to come at the denominator. So sin 3x by 3 plus c. This is your third question. Integral e power 2x. So whenever we have integral e power x, we have to write the same answer as e power x plus c. So the answer is going to be e power 2x. We already know that as x has a coefficient, 2 should come in the denominator. So e power 2x by 2 plus c. Then the fourth question. Here it comes as ax plus b the whole square. So it comes like a polynomial equation. So first we should go with the formula a plus b the whole square is equal to a square plus 2ab plus b square. So then here ax the whole square. The fourth question is integral ax plus b the whole square, which is ax plus b to the whole square is in the formula as integral x power n, which is x power n plus 1 by n plus 1. So here comes the answer as ax plus b the whole cube by 3. But we know already if x has some coefficient, it has to be written in the denominator. So it is ax plus b the whole cube by 3a plus c. Now we go with the fifth question. Now the fifth question is integral sine 2x minus 4 e power 3x. Here we have two different formulas in a same question. So we know the formula of integral sine x is equal to minus cos x, and we also know that integral e power x is equal to e power x plus c. Now we are going to use this both the formulas in one question. So how we are going to write the answer? First we'll split the integrals into two. One is sine 2x minus integral 4 e power 3x. Now your question is changed into like this. So the answer could be for sin x we have the answer as minus cos x. So integral sin 2x will be is equal to minus cos 2x, and we have to write the coefficient in the bottom. So minus cos 2x by 2. Now we go with the second term as integral 4 e power 3x. So make sure that whenever you have a constant before any of the formula questions like e power x, sin x, cos x, so you can just take out the constant out. So now our question turn into 4 integral e power 3x. We know very well that e power x is equal to e power x plus c. So our answer is going to be e power 3x by 3. So now we write the answer together. So the final answer for the question is minus cos 2x by 2 minus 4 e power 3x by 3 plus c. This is the answer for this question. Now we go to the sixth question. So the sixth question is that integral 4 e power 3x plus 1 into dx. Now we are going to split again this into a two forms. 4 e power 3x dx plus 1 dx. So now we will integrate this. In the last sum we saw that whenever there is a constant before any one term, we are taking it outside. So 4 come outside, integral e power 3x dx plus 1 comes out integral dx. So when we are integrating integral e power 3x, our answer could be e power 3x by 3. And when we are integrating here, integral dx will give you as x. So here we get 1x. So answer is 4 by 3 e power 3x plus x plus c. This is your answer. We'll move to the seventh question. So the seventh question is that integral x square into 1 minus 1 by x square into dx. When you have the terms in the product, first make sure you are multiplying the terms inside. So our question turn out to be x square minus x square by x square into dx. So we can simplify this and write into 1. Now we have two terms. We are splitting into two integrals as integral x square dx one term, integral minus 1 dx one term. So when here it comes in the form of x power n. So we know very well we are going to write it as 2 plus 1 by 2 plus 1. And when we integral 1 into dx, we'll get the answer as x. So the answer is x cube by 3 minus x plus c. So we are moving into our eighth question. In eighth question, we have three different terms. So we are going to split this into three integral. integral ax square dx plus integral bx dx plus integral c dx. So here a is a constant, we are taking it out, so we get x square dx. Here b constant, so we are taking it out, integral x dx. C as constant, so integral dx. So our answer is going to be, as it is x square, we'll make it as x power n plus 1 by n plus 1, it is x cube by 3. Then b to the power 1, so it will get as bx square by 2. Then c, when we are integrating ds, we get the answer as x plus c. Question number 9. Integral 2x square plus ex into dx. So again we'll split into in two terms, which is integral 2x square dx plus integral e power x dx. So our answer is going to be, as 2 is a constant, we know very well that we have to take it out. So we'll get 2 integral x square dx plus integral e power x dx. So our answer is going to be 2 x cube by 3 plus e power x plus c. So we are going to move to our 10th question. So here the question is in the form of a minus b the whole square. So we know the formula, a minus b the whole square is equal to a square minus 2ab plus b square. So first you convert the polynomial equation in the form of an algebraic equation. So we'll write it as root x the whole square minus 2 root x into 1 by root x plus 1 by root x the whole square. I'm just explaining it out very clearly, as this is our a and this is our b. So a square, so root x the whole square minus 2 into a into b plus b square. Now this turns out to be x minus 2, as root x get cancelled, and 1 by x. Now you have to integrate it into an, we have 3 multiple terms, so we are going to make it as 3 integral. Integral x dx as one term, minus integral 2 dx as one term, plus integral 1 by x dx as a other term. So now we have the answer as integral x dx will turn out into x square by 2. As you know very well, x has a power 1, so x power n plus 1 by n plus 1. And as 2 as a constant, when we are integrating integral into dx, we get answer as 2x. And here comes out a new formula. Whenever you have 1 by x as an integral, 1 by x is equal to log x. So here comes the answer as log x plus c. This is a new formula which you have to make sure very clearly. So 1 by x is equal to log x. So our answer is x square by 2 minus 2x plus log x plus c. Now we are going to move to our 11th question. Here the question is in the form of a division. So you first split as separate numerators and denominators. So our question is getting changed into x cube by x square dx plus integral 5x square by x square into dx minus integral 4 by x square dx. Now wherever possible we can make the simplification. So here x cube and x square get cancelled, where we get only x square cancel, we get only 5 dx. Here nothing is there to cancel, so we have it as a 4 by x square. Now we will integrate integral x dx, so which is x square by 2 plus 5 dx. We know whenever we have integral dx, we get the answer as x. So here comes 5x here. Now as we saw in the last sum, whenever we have 1 by x, it is log x. But here we have 1 by x square. So what we are supposed to do is that take 4 as outside and bring this denominator x square to the numerator. It becomes as x power minus 2 dx. Now this is in the form of x power n plus 1 by n plus 1. So our answer is x square by 2 plus 5x minus 4. Here it is x power minus 2 plus 1 by minus 2 plus 1. So what is our answer? X square by 2 plus 5x minus 4 x power minus 1 by minus 1. So our answer is x square by 2 plus 5x. This minus become plus. Then x power minus 1, we can take it to the bottom. It becomes 4 by x plus c. This is the answer. We should make sure that whenever we get only 1 by x, we are making it as a log x. Apart from that, when you have x cube, x power 4, x power 5 in the denominator, you are supposed to bring it up and bring it in the form of x power n plus 1 by n plus 1. So now we have 12th question, which is in the same similar formula. So we are going to split it in 3 types. So x cube by root x dx plus integral 3x by root x dx plus integral 4 by root x dx. So you have to, we cannot cancel, so we'll take it up. X cube, x power minus half dx plus 3x into x power minus half dx. This x power minus half is nothing but root x is x power half. When you are taking it up, the sign will get changed. Plus integral 4x power minus half dx. So in the last sum, we have like integral x cube into x power minus half dx plus 3x into x power minus half dx plus 4x power minus half dx. How we have to simplify? When we have base same, powers will get added. That is like x power m into x power n is equal to x power m plus n, which we have learned in our small classes. So this is going to be x cube into x power minus half. So we have to write as x power 3 minus half. When you are taking it as an LCM, 6 minus 1 by 2, which is x power 5 by 2. So now the first term is getting converted into x power 5 by 2 dx plus, now we will work it off, x into x power minus half, which is x power 1 minus 1 by 2, which is x power 2 by 1 by 2. So where we will get as x power half dx, and the third term we already have 4x power minus half dx. Now we will go into the formula like x power n plus 1 by n plus 1. So x power 5 by 2 plus 1 by 5 by 2 plus 1 plus 3 x power half plus 1 by half plus 1 plus 4 integral x power minus half plus 1 by minus half plus 1. So what we get as answer here, we will get, when you get taking it as LCM, x power 7 by 2 by 7 by 2 plus 3 x power 3 by 2 by 3 by 2 plus 4 x power half by half. So you can just reciprocal the denominator term. You will get as 2 by 7 x power 7 by 2 plus 3 into 2 by 3 x power 3 by 2 plus 4 into 2 x power half plus c. So your final answer could be 2 by 7 x power 7 by 2 plus 3 cancel, 2 x power 3 by 2 plus 8 x power half plus c. So 13th question, integral x cube minus x square plus x minus 1 divided by x minus 1. So when you have something like that, if you able to take something as common and cancel out, we can do that. Now in this question, in the first two terms, we can take x square as common, where you will get x minus 1 plus x minus 1 divided by x minus 1. Now we are taking x minus 1 common from the numerator. When you take out x minus 1 common, you will get as x square plus 1 divided by x minus 1. Numerator and denominator will get cancelled. So integral x square plus 1, you will get it as, so when you are integrating, you will get as x cube by 3 plus x plus c. This could be your final answer. Now we move to the 14th question. As we already saw a question, when we have something in product, we have make sure you have to multiply both inside. So you'll get as root x minus x root x into dx. Now we are splitting it into two terms, root x dx minus integral x root x dx. So what could be your answer? So this term is nothing but x power half dx, and in this term, it is like x power 1 into x power half dx. So base same, power is going to get added. So it will become as x power 3 by 2. So now your question is integral x power half dx minus x power 3 by 2 dx. Now it is in the form of x power n plus 1 by n plus 1. So which is x power 3 by 2 by 3 by 2 minus x power 5 by 2 by 5 by 2 plus c. Question number 15. Which is also in the product form. So first make sure I'm multiplying with all the three terms. So where you will get 3x square into root x plus 2x into root x plus 3 root x. Whole term has a dx. So now first we'll simplify the x terms. We have here x power half into x power 1 by 2 plus 2x into x power half plus 3 into x power half. So the first term could be of 3x power 5 by 2 dx plus integral 2x power 3 by 2 dx plus 3x power half dx. Now everything is in the form of x power n plus 1 by n plus 1. So our answer would be 3x power 7 by 2 by 7 by 2 plus 2x power 5 by 2 by 5 by 2 plus 3x power 3 by 2 by 3 by 2 plus c. So I'm just solving it out here. So yeah, you have a term as 3x power 5 by 2. How it is getting changed into 7 by 2? So it is in the form of x power n plus 1 by n plus 1. So which is x power 5 by 2 plus 1 by 5 by 2 plus 1. When you take out LCM for 5 by 2 plus 1, it becomes 5 plus 2 by 2, which is 7 by 2. So there comes 3x power 7 by 2 by 7 by 2. You have to repeat the same steps for the next two terms. Now we are moving into our 16th question. Question is integral 2x minus 3 cos x plus e power x dx. So first we will split into it three terms. Integral 2x dx minus integral 3 cos x dx plus integral e power x dx. So your answer could be 2, you take the constant out. So you'll have x dx minus 3 integral cos x dx plus integral e power x dx. So your answer is 2. This is in the form of x power n plus 1 by n plus 1. N is 1. So your answer is x square by 2 minus 3 cos x. You will have an integral. Integral cos x is equal to sin x. So 3 sin x plus e power x. You can cancel out this 2. So your final answer is x square minus 3 sin x plus e power x plus c. So now it is our 17th question. So our 17th question is integral 2x square minus 3 sin x plus 5 root x into dx. So the first step, as we have it as three terms, we'll split it as three terms. Integral 2x square dx minus integral 3 sin x dx plus integral 5 root x dx. So now we will take out the constant outside. 2x square dx minus 3 integral sin x dx plus 5 integral root x dx. So we'll go into the formula. This is in the form of x power n. So our answer is x power n plus 1 by n plus 1 minus 3 integral sin x. So integral sin x is minus cos x. So here comes, so minus cos x plus 5 x root x is as x power half dx. Now it is in the form of x power n plus 1 by n plus 1. So our answer is 2 by 3 x cube. Minus into minus becomes plus 3 cos x, and here it comes x power n plus 1 by n plus 1. So half plus 1 is nothing but 3 by 2. So x power 3 by 2 by 3 by 2. So now we will simplify it as like 2 by 3 x cube plus 3 cos x plus 5. When this 3 by 2 comes up, it becomes as reciprocal 2 by 3 into x power 3 by 2 plus c. This is your final answer, where you could write this as 10 by 3. So answer is 2 by 3 x cube plus 3 cos x plus 10 by 3 x power 3 by 2 plus c. Now we are going to go to our 18th question. So we know that when some terms are in the product, we should make sure we are multiplying with each terms inside the bracket. So first our question is getting changed into secant square x. Secant x into secant x is nothing but secant square x plus secant x tan x into dx. Now we have two terms, so we are making it to an two integral. Integral secant square x dx as one term plus integral secant x tan x as the other term. So integral secant square x, we have a formula as integral secant square x is equal to tan x. So the first term integral secant square is nothing but tan x. And the second term is secant x tan x. What is secant x tan x? Integral secant x tan x is equal to secant x. So this term becomes as secant x. So this is your answer. Your answer is tan x plus secant x plus c. Now we go to our 19th question. 19th question, integral secant square x by cosec square x. So we know that secant x is equal to 1 by cos x. Cosec x is equal to 1 by sin x. So we'll write it in that form. Secant square I'm writing as 1 by cos square x. Cosec I'm writing as 1 by sin square x. So when it is getting reciprocal, it comes as sin square x by cos square x. So what is sin by cos? Sin x by cos x is equal to tan x. So sin square x by cos square x is nothing but tan square x. Do we have any formula for tan square x? Actually we don't have. So we can write it as tan square is nothing but secant square x minus 1. This is the identity. Secant square x minus 1 is equal to tan square x. So now we have formula for secant square is nothing but tan x. So answer is, now we have two terms. We will split into two integral. Integral secant square x dx minus 1 dx. So secant square x is nothing but tan x. 1 dx is nothing but x plus c. This is your answer. You should make sure that We don't have formula for tan square x, so we are using the identity tan square x is nothing but secant square x minus 1. So I'm replacing this tan square into secant square minus 1. Now I'm splitting it into two integrals, and then I'm integrating and writing the answer. So here comes the last sum for the first exercise. So now it is in the division form, so we are splitting it into two terms. 2 by cos square x as one term and 3 sin x by cos square x as the next term. So 1 by cos square, I written here already, 1 by cos is nothing but secant square. So this term turn out to be 2 secant square x. And what is this term? We know sin by cos. I'm just showing you here. Sin x by cos x into cos x. We know 1 sin by cos is nothing but tan and 1 by cos is nothing but secant. So the second term is getting converted into 3 sin 1 sin by 1 cos into tan. But we have other 1 by cos which I am turning out into an secant x. Now we know we have a formula as for secant square x we have tan x, secant x tan x we have secant x. So our answer is 2 tan x minus 3 secant x plus c. And here our first exercise getting end. Hope you all understand, and our first exercise getting over here.